Hi to all. How are you? Today's topic is cells in series. When we say that the cells are in series. In the last class we discussed about the cell, terminal voltage, EMF, internal resistance and the relation between them. And now I am going to explain when we say that the cells are in series. Previously we also discussed the series combination of resistors, series combination of capacitors. Now I am going to tell the series combination of cells in series, right? When we say that the cells are in series, let us see if the negative terminal of first cell, okay, if the negative terminal of first cell, negative terminal of first cell connected to the positive terminal of second cell and so on, then the cells are said to be in series. Cells are said to be in series. Okay, now I will draw the diagram for this. Let us see this. This is the first cell. Its EMF we can consider as E1 and internal resistance is R1. Okay, remember that EMF denoted like this, epsilon. We can read it as E only. Why we cannot denote with E? Because E means already electric field intensity is there. That's why I am denoting with this epsilon. I will read it as E, and this capital E is the electric field intensity. Okay, capital E is the electric field intensity. In some books for the EMF also we can denote with capital E, but we should not confuse, right? And now I am going to continue. This is the first cell, okay, and next this is the second cell. The first cell EMF is E1, internal resistance is R1, and the second cell EMF is E2 and internal resistance is R2. E1 R1, E2 R2. Okay, these two cells are connected like this. This is the positive terminal of cell, negative terminal of cell, positive and negative. Negative terminal of the first cell connected to the positive terminal of the next cell and so on. Then the cells are said to be in series. And this combination is connected to some external resistance, that is capital R. And now the potential difference across the first cell we can consider as V1. The potential difference across the second cell we can consider as V2. That potential difference across the two terminals of cell, it is also said to be terminal voltage. The current starts from the positive terminal of battery and the current flows like this. The current in this circuit is considered as I. Current is I. Okay, and now let us see the equivalent diagram for this. I will draw. If these two cells will act as one cell, okay, its EMF is E equivalent and its total internal resistance is R equivalent. If two cells combinedly act as one cell, then what is the total EMF and what is the total internal resistance? Okay, and the external resistance is capital R and the total voltage is V. The total voltage is V. Okay, two cells will act as one cell, and now the two cells are in series. Now I want to find out the effective EMF. For that, E1 E2 are what? E1 E2, E1 comma E2 are the EMFs of two cells, right? EMFs of two cells. And R1 comma R2 are what? Internal resistances of two cells. Internal resistances of two cells. Then what is E equivalent? What is E equivalent? Okay, E equivalent is the effective EMF, effective or equivalent, effective or equivalent EMF in series combination of two cells, right? Okay. R equivalent is the effective or equivalent internal resistance. Now let us see. I am going to explain how to find out the terminal voltage across the first cell. We know already, for example, this is a cell, its EMF is E and internal resistance is R. It is connected to some external resistance, capital R. The current starts from the positive terminal and it goes like this. Okay, and now the potential difference across the two terminals of cell is V. Its formula is V is equal to E minus IR, right? This is when current extracted from the battery. When the current comes outwards from the battery, then we write V equal to E minus IR. The relation between the terminal voltage and EMF. Previously we discussed, right, in the last lecture, that is lecture number, part number 3.8. Okay. Now let us see terminal voltage across the first cell. I am going to write terminal voltage across first cell. Yes, what is the terminal voltage across the first cell? Terminal voltage is nothing but potential difference across the first cell. Potential difference across the first cell is V1. That we write V1 formula is, we know formula, terminal voltage is formula V equal to E minus IR. Then here V1 is the terminal voltage across the first cell, that is equal to E1 minus current in this circuit, this series combination is same, that is I. Then we write E is E1 minus current is I, internal resistance of the first cell is R1. This is equation 1. And then terminal voltage across, terminal voltage or the potential difference, simply we can also write potential difference also. Terminal voltage equal to potential difference across the second cell, right? And that is V2. Across the second cell, the terminal voltage is V2. Its formula is again E minus IR. E is E2 minus I into R is R2. This is equation 2. Okay, this also from V equal to E minus IR. Why we are not writing I1, I2? Because in series combination same current flows. Okay, current is constant. And the next, if these two cells will act as one cell, the net voltage is V. Net terminal voltage we write as net terminal voltage at equivalent cell across equivalent cell. What we write? Yes, the net terminal voltage at equivalent cell, we want V. If these two cells is, that means total, right? If two cells will act as one cell, then the total voltage is V1 plus V2 at here. Here we are considering that only. Then we write V is equal to, we write V1 plus V2 we can write. V is equal V1 plus V2 we write. And here we substitute V1 formula and V2 formula. Okay. Then V is equal to, V1 is the E1 minus IR1 and V2 is E2 minus IR2. Then we write V is equal to E1 plus E2 minus IR1 minus IR2. Minus I is common in this. Okay. Then we will get minus of I into R1 plus R2 we will get. This is equation 3. And the next I am going to compare with the terminal voltage across the net terminal voltage, right? Net potential difference. Net terminal voltage we can also write like this. Net terminal voltage or the terminal potential difference. Terminal means terminal or the potential difference. Terminal voltage Okay, terminal voltage or the potential difference. What is the net terminal potential difference? We write net voltage is V, net EMF is E equivalent, minus net current is I, the current in the circuit is I. Then we write I R equivalent, we write. Okay, this is equation 4. And this also I am writing from where? V is equal to E minus IR formula. Here net voltage means net EMF we have to write minus I, net current into net resistance we have to write. Compare the equation 3 and equation 4. Then we will get the, compare equation 3 and equation 4. When we compare these two equations, we will get effective EMF formula, right? Effective EMF formula we will get E equivalent is equal to look at here V, E equivalent E1 plus E2 minus I, R equivalent R1 plus R2. That E equivalent effective EMF is equal to E1 plus E2 we got. This is equation 5. And the effective internal resistance, what you will get? Effective internal resistance. What you will get? Compare it. Just you will compare and you will get it. R equivalent, R suffix EQ. R equivalent, E equivalent means E suffix EQ. Okay, E means we are writing here like this, epsilon. E equivalent, R equivalent, effective EMF, effective internal resistance. Okay, and now effective internal resistance R equivalent, R suffix EQ is equal, R suffix EQ is equal R1 plus R2 we are writing, right? This is equation 6. Now how to find out the effective EMF? You can compare this here. R equivalent, here I is there. In place of R equivalent, what is there? R1 plus R2 is there. That means if two cells of EMFs E1 and E2 are connected in series, then if two cells will act as one cell, their effective EMF, total EMF, how much you will get? That effective EMF or the total EMF is equal to sum of EMFs of individual cells E1 plus E2. And effective internal resistance is what? Inside the cell, here it has some resistance. Inside the cell it also has some resistance. The resistance offered by the electrolyte of a cell is called as internal resistance. That this R1 and R2 cells are in series, means the internal resistance also in series. In series effective resistance we will get R1 plus R2. This is R equivalent. And now in series combination, if you want, we are getting the total EMF is, that is effective EMF is equal to sum of EMFs of individual cells. That means if you connect the 1.5 volt, 1.5 volt two cells are in series, then you will get the total EMF, net EMF is 1.5 plus 1.5. That means 3 volt you will get. That means if you want to get more EMF, that we are adding, when you will add, you will get more EMF. If you want the more EMF, more potential difference, more voltage, then at that moment you have to connect the cells in series. Right? And this is about a series combination of cells, and you take a screenshot and write the notes. Okay, and now let us go for some more information related to series combination. Here I am telling that the cells are in series, only 2 cells we are taking. If n cells of EMFs E1, E2 and so on En are connected in series, then what is the effective EMF? Okay, right. Similarly, if n cells connected in series, okay, then effective EMF formula is E equivalent, okay, E equivalent, E suffix equivalent is equal E1 plus E2 plus, or more are there, means we have to do the plus, then we will get equivalent EMF is E1 plus E2 plus and so on En. And now I want the effective internal resistance, right? This is effective EMF. If you want the effective internal resistance, we have to add same R1 plus R2 plus and so on Rn. Okay, Right. Now one note point I am going to give, right? The one point important is that there is, if two cells connected like this, E1 and internal resistance is R1, and the next second cell E2 and internal resistance is R2. This is exact series combination, right? Negative term, positive terminal, negative terminal, positive terminal, negative terminal, right? And now negative terminal of first cell connected to the positive terminal of next cell, then the total EMF we will get as equivalent EMF as E1 plus E2. Just we have to add them. And effective internal resistance is what? R1 plus R2. But the same thing in the series, if you connect the second cell wrongly, if in series, if polarity or terminals of second cell reversed, then what happens? What is the effective rest EMF? Just like this it is there. This is the first cell, and the next, actually we have to connect the negative terminal of first cell to the positive terminal of the next cell, but we are connecting to the negative terminal only, right? This is the wrong connection. It has the EMF E1, internal resistance R1, and it has the EMF E2, internal resistance R2, right? Then at that moment, what is the total EMF? What is the total EMF? The effective EMF we write as either E1 minus E2 or E2 minus E1. If E1 is greater than E2, we can write effective EMF as E1 minus E2. If E2 is greater than, then we write E2 minus E1. If the cells are connected wrongly in series, okay, above cells are connected wrongly in series but wrong connection, okay, that is, this is, if in series, if terminals of second cell reversed, that means wrong connection, right? Wrongly connected, right? If we connect wrongly, then what happens, right? Then what is the effective EMF? Here we have to subtract, but here if E2 greater than E1, we have to take E2 minus E1, and if E1 is greater than E2, then E1 minus E2 we have to write. We have to subtract, not adding, right? Exact series combination we have to add, but if wrong connection is there, then we have to subtract. Look at here, negative terminal of first cell connected to positive terminal of second cell means that is the right connection in the series, and negative terminal is connected to the negative terminal of the next cell, then this is the wrong connection in the series. Then effective EMF formula is E1 minus E2 or E2 minus E1. We have to subtract, okay? And effective internal resistance, what happens? Effective internal resistance in this case, what happens? Effective internal resistance, yes, what happens? Tell me. Effective internal resistance is, okay, we cannot get the R1 minus R2 because this is the first cell resistance is R1, second cell resistance is R2, okay. There is no wrong connection for the resistors not have the positive second negative terminals. If you reverse the terminals, then there is no problem, okay. This is A and this is B and this is C. For example, if you connect like this R1 and I am reversing this, here B and this is R2 and this is A, you can reverse this, no problem, right? Then also we will get the effective resistance as R1 plus R2. That means in the wrong connection or the right connection, the effective resistance is the same, that is R1 plus R2, okay. Only in EMF it is different. And now let us see, here we are connecting the different cells. If identical cells, if you will connect, then what happens? How to derive the formula? Now let us see, n identical cells are connected in series. Take the screenshot and note it. Now I am going to explain, if n identical cells are connected in series, then what is the formula to find out the effective EMF? It was very easy to find out it, okay. If you will get any doubt, you can ask me and comment in the YouTube, and also personally you can contact me in WhatsApp number. Okay, let us go for the next one. The next one is what? Right. The thing is that n identical cells. Okay, this is also one point in the note I am going to tell. Okay, and n identical cells are in series. Okay, n identical cells are in series. Then what is the formula to find out the effective EMF? Look at here, there are n identical cells, each of n identical cells of each EMF, n identical cells, each of EMF epsilon and internal resistance small r are connected in series. Their combination is connected to external resistance capital R. Then what happens? Let us see. Okay, what I am doing it here, there are n cells. Okay, this one first cell EMF E and internal resistance R. The second cell EMF E, internal resistance R. And like this there are many cells I am connecting in the series, right? And how many cells I am connecting? N cells I am connecting, and their combination is connected to some external resistance capital R. Then what is the formula to find out the effective EMF? What is the formula to find out the effective EMF? Okay, all are the right connection. Then the formula for the effective EMF, in this case what they give here, all the EMFs are of all cells is same. Okay, E1 is equal to E, E2 is equal to E, En is equal to also E. Internal resistance is also same, R1 is equal to R2 is equal to, and so on, Rn is equal to R. Then effective EMF formula, right? Effective EMF formula is, tell me, E equivalent is equal to, formula is what? E1 plus E2 and so on, En. But all are equal, right? E plus E plus E plus we have to write. E plus and so on E. What you will get the effective EMF? Yes, that we will get as Ne. This is the effective EMF formula. Okay, because here n cells are there. Only 2 are there means E plus E 2E, 3 are there means 3E, n are there means Ne we have to write. And the next, let us see if what about the internal resistance? Effective internal resistance is what? Effective internal resistance. Okay, I am going to explain what effective internal resistance. That is, effective internal resistance I want to find out. Effective internal resistance. That is, in the series combination, R equivalent is equal, we have to add just R1 plus R2 and so on Rn. But all are same, identical cells. All the cells have the same EMF and the same internal resistance. Then the equivalent resistance we will get is NR, right? R is the internal resistance of each cell. And the next, what is the current through the external resistance? current through the external resistance, capital R. Look at here, these n cells combinedly act as one cell. Its EMF is Ne and its internal resistance is Nr. It is connected to some external resistance, capital R. Then some current flows at here. What is that current I want? They are asking, right? In this case, how much current flows? This current formula I want to know, right? How to find out the current? Very simple to find out the current. In the last class we discussed the current formula according to Ohm's law, V by R. But we can also write the current formula as effective EMF by effective internal resistance. Effective EMF by effective resistance. Effective resistance we have to write. What is the effective EMF? The total EMF we can also write like this. Effective EMF is E effective. External resistance is only one, capital R, plus internal resistance effective is R effective, we can write. Okay, effective EMF is E effective. Effective resistance is, for the cells effective resistance is E effective, R effective. Okay, R equivalent we are writing, na? Right, E equivalent, E suffix EQ, R equivalent, R suffix EQ. Okay, total resistance, right, this is E equivalent. Okay, this is R equivalent. If these all cells combinedly act as one cell, its EMF is equivalent and its internal resistance is R equivalent. Then the current is EMF by total resistance. Total resistance is what? Capital R plus internal resistance of the cell is R equivalent. External resistance is capital R. Total is capital R plus R equivalent. Then what we write the formula? Yes, E equivalent we know already. Ne by effective resistance is what? External resistance capital R. Combined resistance of these all cells is Nr. Right? Capital R plus Nr we write. This is the current formula in series combination of identical cells. Okay, series combination. And now, for example, if the total internal resistance is very much less, right, then what happens? One case if you will take, if Nr less than capital R, then what happens? This Nr is neglected, then Ne by capital R we will get, right? Okay, this case is no need to write. No. Okay, this is the formula for the current. This is for series combination. And let us see, and one more point I am going to tell. Here in the series combination, all the cells are connected correctly. If out of n cells, if some cells are wrongly connected, then what happens? All the n cells are connected in correctly now. Then effective EMF is Ne, just we have to add them. Right? If some cells are wrongly connected, then what happens? I will rub totally and I will start that class. Okay? Okay, look at here. The next topic is in the series combination, right? If wrongly connected, in identical wrongly connected, okay, then what happens? Look at here. N cells each of EMF E and internal resistance small r are connected in series, and by mistake M cells are wrongly connected. Total n cells are there. By mistake in that M cells are wrongly connected. Then what is the effective EMF and effective resistance? Look at here. There are some cells are there. Total n cells. In that M cells are wrongly connected. That means what? For example, here you see this is 1, 2, 3. Negative terminal of the first cell connected to the first terminal of the next cell, and so on. This is the right connection. But here negative connected to negative, this is the wrong connection, right? And here there are some cells are wrongly connected. Then that is out of n cells, total n cells, in that M cells are wrongly connected. Then what is the effective EMF? For this, for example, I will tell the example for this. For example, there are 5 cells are there, okay? EMF E and E, and the next E and E. Look at here, there are 5 cells, right? There are how many cells? 5 cells. All are identical. Now what is the effective EMF in this case? These 3 cells, total 5 cells, right? Total 5 cells. Here n cells are, total 5 cells are in series, end to end 5 cells are in series. 5 cells in series. But by mistake 2 cells are, polarities are reversed. Terminals are reversed. Negative connected to positive. Negative connected to positive. But the negative connected to negative, that means it is wrong. Right? Here also negative connected to negative. These 2 cells are reversed. Look at here. Negative positive, negative positive. These are correct connection. And here positive connected to negative. Right? Look at here. These 2 cells are reversed comparing with these 3. That's why out of 5 cells, 2 cells are, polarities are reversed, terminals are reversed. Okay, all the terminals, positive left side, negative right side, positive left side, negative left side, right side, positive left side, negative right side here. But here what happens? Negative left side, negative left side. That means it is reversed. These 2 cells are reversed. Then how to find out the effective EMF? Look at here. These 3 cells are rightly connected. These 3 cells are rightly connected. That means total EMF is 3 and these 2 cells are wrongly connected, but their total EMF is 2E. Okay, then what is the net EMF? The effective EMF is 3E minus 2E, that is 1E. Okay, once again I will tell. There are total 5 cells. In that 3 cells are rightly connected, right? Their effective is 3E. 2 cells polarities are reversely connected. Their effective is 2E, right? The total EMF is rightly connected minus wrongly connected. Then due to the wrong connection, effective EMF will be decreases. How much decreases? 2 connected wrongly, that's why minus 2E. Then we will get this one, right? And how we are finding it here? Correctly connected EMF minus wrongly connected EMF. Then we will get the total EMF. Then here out of n cells, m cells are wrongly connected. Here out of 5 cells, 2 cells are wrongly connected. Out of 5, 2 are wrong. That means how many right? Total 5. In that 2 are wrong. Means 3 are right. Then similarly here total n, m are wrong. That means right connected is, yes. Tell me how many rightly connected? Effective EMF is equal E equivalent is equal out of n cells, m cell wrongly connected. That means out of 5 cells, 2 cells wrongly connected, means rightly connected cells are 3 cells. Alright, n minus m into epsilon E minus, this is effective EMF of rightly connected cells. Wrongly connected EMF is what? Wrongly m cells are connected, their EMF is me, right? This is total EMF generated by the cells which are connected correctly. This is the total EMF of cells which are connected wrongly. Then effective EMF if you want, right? Then we have to subtract them. Then we will get effective EMF as n minus 2m into epsilon. You remember this one, okay? Out of n cells, if m cells are wrongly connected, then we will get this formula. Look at here. Total how many cells are there? 5 cells are there. How many wrongly connected? Right, wrongly connected is 2. In this, you substitute in this, whether we will get the same or not. Equivalent EMF 5 minus 2 into 2 into epsilon. Then what you will get? 5 minus 4 into E. Then we will get 1E, right? Okay, this is the right formula to find out the equivalent EMF. Now, the next one is, what is the effective internal resistance? Effective EMF we find out. Okay, effective internal resistance I want. Effective internal resistance. Effective or equivalent internal resistance. Effective or equivalent internal resistance. Okay, what is the effective internal resistance? Just we have to add them. R plus R plus R plus R plus R plus. There is no wrong connection for the resistors because resistors not have the positive negative terminals. That directly we write NR. N cells, N resistors. Each of resistance is smaller, R plus R plus R plus R plus R. N cells are there total, that's why NR we will write, because there is no wrong connection in the further resistors. Resistors not have the positive negative terminals. If you reverse the polar terminals, then there is no problem. Now the current through the external resistance I want. Current through the external resistance. How to find out the current? Very simple, right? Effective EMF by effective resistance. This is the formula to find out the effective current. This is nothing but effective EMF total EMF by total resistance. Effective resistance in the circuit. Yes, what is the effective EMF in the circuit? We are taking it as E equivalent. What is the effective resistance? External capital R, internal R equivalent. Then we write like this. The total EMF is N minus, total EMF is what, tell me? N minus 2M into E by the total resistance is external capital R and internal is NR. This is the current formula. This is the current formula. Okay. And now let us go for one problem based on this. Very simple problem I will give. Okay. Right. I will write the question by pressing the pass key. Okay. Look at here. One problem based on the series combination of cells. Let us see here. There are 12 cells. Each of EMF 2 volts are connected in series. How many cells are there? 12 cells are there. Each of EMF, the number of cells is 12, all are identical. Each of EMF 2 volts, right? EMF is 2 volts are connected in series. Among the 12 cells, how many cells are wrongly connected? 3 cells connected wrongly. That means M value is 3. The question is that find the effective EMF of combination. Effective EMF, okay? Effective EMF denoted with like this, E suffix equivalent. In some books, E suffix effective they will write. Or in some books, capital E equivalent they will write. Or the capital E effective they will write. Okay. And now any one notation you have to follow, don't confuse, right? And then what is the formula? E equivalent formula is same. Here the total N cells, out of that M cells wrongly connected. Then effective EMF formula this one. Then here effective EMF formula is N minus 2M into E, right? And all the values you know, you substitute in this, you will get answer. N is 12 minus 2 into M is 3. E value is how much? 2. Right, we will get answer as E equivalent is equal to 12 minus 6. 12 minus 6 into 2. Right, we will get 6 into 2. Then we will get 12 volt. This is our solution. Okay, and this is about series combination. Now let us start the parallel combination. Okay, before going to parallel combination, you take the screenshot and note every point, and I am going to rub the total board, okay, by pressing the pass key. Okay, let us continue the parallel combination of cells. Okay, cells in parallel combination. Previously we discussed about the series combination, right? Now I am going to explain the parallel combination. Then here, look at here, when we say that the cells are in parallel, right? Now these two cells are in parallel. Positive terminal of the two cells connected to one point, negative terminals of the two cells are connected to another point. Then the cells are said to be in parallel combination. All the positive terminals connected together, all the negative terminals connected together, then the cells are said to be in parallel combination. And look at here, in this parallel combination, right, the current starts from the positive terminal of the first battery and second battery also. That current I1 and I2, it will combine and it will go through external resistance capital R. Right, here we write I1 is coming this side, is I2 coming, the two combinedly it will goes like this. That means I is equal to, we write I1 plus I2, I1 is coming this side, I2 is coming this side, then it goes like this I. Then we write I is equal to I1 plus I2. Okay, and look at here, this is I is coming at here, then it will goes like I1 and I2. And now, but this in the parallel combination, we know the potential is same, right? In parallel combination, what is constant? In parallel combination, but terminal voltage or potential difference across each cell, potential difference is remains constant, right? Is remains constant, means potential difference across the first cell equal to potential difference across the second cell. Terminal voltage across the first cell V, second cell also V. EMF of first cell E1, second cell E2. Internal resistance of first cell R1, internal resistance of second cell R2. Okay, current extracted from first cell is I1, current extracted from the second cell is I2. Now, how to write the current formula, current extracted from the battery or the cell E1. Okay, now for that, current extracted from first cell whose EMF is E1, right? Current formula to find out that, we use V, same terminal voltage formula we use. Terminal voltage formula V is equal to E minus IR, right? Terminal voltage formula is what? V is equal to E minus IR. In this current formula I want to find out, right? IR is equal to what you will get? You take this equal to E minus IR. We will take IR to left side, V to right side. IR is equal to E minus V. R is equal to what you will get? We want to find out the current, right? Current is equal to, we write E minus V by I, or E by I minus V by I we write, or another way directly E minus V by I, R also we write, right? Look at here, we are taking the R to right side, not I. I is equal to what you will get? E minus V by R. I is equal to E minus V by R we will get, right? And from this we will get I formula as E minus V by R we will get, right? Okay, I is equal to E minus V by R we will get. Now, current extracted from the first cell, instead of I we will get I1, right? I1, I suffix 1 is equal from the first cell. First cell EMF is E1. Potential difference across the first cell is V by the resistance of the first cell is R1. We write this as E1 by R1 minus V by R1 we write. This is equation 1. Understood? Right. Now current extracted from the second cell, let us write. Current extracted from second cell. Okay. Current extracted or current drawn. Extracted means drawn. Okay. Current drawn or extracted, same way, meaning current drawn from second cell. What is that? That is I2. Yes. Current formula what you got from that? I is equal to E minus V by R we write. Current extracted from the second cell is current drawn, taken out from the second cell is I2. EMF of second cell E2. E is E2. Minus potential difference is V. Why? Because potential difference is the same. Terminal voltage is the same because they are in parallel. By the resistance, internal resistance. Here we have to write internal resistance. What is internal resistance? R2. R2 of second cell internal resistance is R2. This we can write as, who do you write? Tell me. E2 by R2 minus V by R2. This is equation 2. This we are writing from the basic formula, that is I is equal to E minus V by R. Right? Okay. And the net current, what we write the net current? Or current through the external resistance. Okay, net current or current through external resistance. Current through external resistance, capital R. What is the total current? I is equal to, we write I1 plus I2 we write. Because this side I1 is coming, this side is I2 is coming, totally combines. Then I is equal to, I1 is what? we write E1 minus E1 by R1 minus V by R1 plus E2 by R2 minus V by R2. Look at here, just we have to add this and this, I1 and I2. Then here we write E1 by R1 plus E2 by R2, we have to write. These two we will write at one side, and here next minus V by R1 minus V by R2. V terms one to one side. Here we write like this, E1 by R1 plus E2 by R2. Next minus V is common at here, then we will get 1 by R1 plus 1 by R2, we have to write. Okay, this is equation 3. And now current extracted from equivalent cell, okay, current drawn from equivalent cell is I. Current drawn from equivalent cell, right? From the figure 2 we write the current formula. Here current extracted is I. Yes, the current formula, how we are writing? Current is equal to, we know formula, that is I is equal from here, V equal to E minus I, or I is equal to E minus V by R. E minus V by R, right? Total current extracted from the total cell is total, these two cells combinedly act as one cell, then the current extracted from that cell is I is equal to, what do we write? E equivalent total EMF, total current, total EMF, E equivalent minus potential difference is same in parallel combination, R is R equivalent. We write like this, this one I is equal to E equivalent by R equivalent minus V by R equivalent, V by R equivalent. V by R equivalent we write, that we can also write as V into 1 by R equivalent, we write. This is equation 4. Now at almost the derivation will be completed. Let us start. Okay, take the screenshot and note it. Can I rub? Okay. Can I rub? Take the screenshot and write it. And now I am going to rub it and continue. It was very simple to find out. Okay, look at here. Compare. What we have to do next? Comparison. Compare equation. Compare equation 3 and equation 4. Equation 3 and equation 4. Right, when we compare here, I, E equivalent by R equivalent is equal to E equivalent by R equivalent is equal to this place, here it is occupied by this one, minus V 1 by R equivalent is 1 by R1 plus 1 by R2, right? E equivalent is E1 by R1 plus C2 by R2, right? This formula we will use to find out the effective EMF. Okay, this is equation 5. And if 1 by R equivalent, what we write? 1 by R equivalent we write as, tell me, you compare. This is V. 1 by R equivalent is 1 by R1 plus 1 by R2. 1 by R1 plus 1 by R2. Okay. In parallel combination, effective EMF we can find out by using this formula. Effective resistance we can find out by using this formula. Okay, from this R equivalent we write from equation 6. Okay, from equation 6, R equivalent what we write? R1 R2 by R1 plus R2, parallel combination. When you will do the LCM, we will get this one. Now R equivalent is substituted in equation 5. Then what you will get? E equivalent by R equivalent is what? R1 R2 by R1 plus R2 is equal to, right side E1 we have to do the LCM, right? E1 by R1 plus E2 by R2 we have to write. Okay, do the LCM and simplify it. E equivalent by R1 R2 by R1 plus R2 is equal to E1 R2 plus E2 R1 by R1 R2. We will take this term to right side, right? Then we will get E equivalent is equal to E1 R2 plus E2 R1 by R1 R2 into R1 R2 by R1 plus R2 we will get. This will cancel. Final formula we will get. What you will get the final formula? What can you tell? The final formula for the effective EMF directly we can find out, right? Now for that we have to rub this and let us continue, and more 10 minutes required to complete this lecture. Let us start. And what you will get the answer? Can you tell? The answer is E equivalent is equal to E1 R2 plus E1 R2 plus E2 R1 by R1 plus R2, right? This is the formula for the effective EMF when two cells are connected in series. This is equation 6. Okay, and now I am going to tell some points in the note. That is, the first point is that if n cells are connected in series, right? If n cells are in series, if n cells are in series, then what is the formula to find out the E equivalent by R equivalent is equal to E1 by R1 plus E2 by R2, or for the only two cells, this one, and next and so on. N cells are there, means En by R, and we write. What about the R equivalent at here? To find out the R equivalent, the formula is 1 by R1 plus 1 by R2 and so on, 1 by Rn. This is equation 8 and 9. Okay. Now, if identical cells are connected in parallel, then what is the effective EMF and what is the effective internal resistance? How to find out the current? With that I will close. Okay, I will start. I will rub total and I will start continuation class. I am pressing the pause. Okay, look at here. Next topic is, in identical cells each of EMF E are connected in identical cells each of EMF E and internal resistance R are connected in parallel, and then their combination is connected to external resistance capital. In this movement what they gave, there are several cells are there, okay, n cells are there, all are identical, right? All are having the same EMF. E1 is E, E2 is E, E3 is E, En is also E. All are having same internal resistance. Okay, then question, what is the effective EMF? Effective EMF, how to find out? Okay, what is the effective EMF and what is the effective internal resistance? For two cells we can find out. For two cells, what is the effective EMF? There is some formula is there, E1 R2 plus E2 R1 by R1 plus R2. This we derived when two cells are in parallel. Two cells have the same EMF. Look at here. Okay, E1 is E, E2 is E, and internal resistance also equal. R1 is equal to R2 is equal to R. ER plus ER by R plus R. 2ER by 2R. This will cancel. Then the effective EMF we will get as E. That means the effective EMF formula is, if when two cells of EMFs, each of EMF E connected in parallel, then their effective EMF is E. That means it is equal to EMF of only one cell. Similarly, effective EMF is in the parallel combination, right? Identical cells, effective EMF equal to E. That means effective EMF is equal to EMF of one cell, right? But in n cells in series means NE, but n cells are in parallel means effective EMF equal to EMF of only one cell, right? Then effective resistance. Effective resistance formula is 1 by R equivalent, 1 by R1 plus 1 by R2 plus 1 by R3 and so on 1 by Rn. Then what you will get? 1 by R equivalent is equal to N by R. Then N terms are there, N by R. That's why R equivalent is R by N. This is the effective resistance in the parallel combination. In parallel combination, same formula is there. N identical resistors, each of resistance capital R connected in parallel, then their effective resistance is R by N. Okay. And how to find out the current? How to find out the current through the resistance? Now, current we can find out, very simple formula is there. Current through external resistance. What is the formula for the current through external resistance? Yes, it was very simple. This is equivalent EMF is E equivalent, internal resistance is R equivalent, and the external resistance is capital R. The current is I. Yes, what is the formula to find out the current at here? The basic formula to find out the current is effective EMF by effective EMF, equivalent EMF by effective resistance, right? What is the effective EMF? E equivalent or E effective, E suffix small eq, E suffix eq by capital R plus R effective is R equivalent. Okay. Now effective or equivalent, both are same. Then the current formula is E equivalent is E by capital R plus R equivalent is what? R by N. R by N. This is the formula for current in parallel combination, right? With this we completed the series and parallel combination. Okay, write every point in the notes and practice the derivations of effective EMF in the series and parallel combination. If you have any doubt, you can ask me. Now my WhatsApp number is 9963817138. This is my WhatsApp number. You can WhatsApp for the doubts, and you can also comment in the YouTube. Thank you for watching my lectures. Share my channel to your friends and nearby one, and also subscribe my channel. Thank you.